This video documents how the prototype was created and how the finished product addresses the focus of sustainability and innovation in this unit. I used a specialized slot cutting bit on a router to cut the slots that hold the plastic edging I plan to attach to the finished cabinet. This was quite a straightforward task. I centered the router bit to the center of the plywood and simply ran the slot cutter along every visible edge. Whilst using the router, I followed all the relevant safety procedures. Following the same process of measuring, cutting and fitting, the cabinet began to take shape. I mainly used the panel saw with my drill and impact driver to complete this stage of the build. Besides the steel ruler, the sliding bevel was my best friend as it helped me find and set the necessary angles that needed to be cut. To mount the screen into position, I took the mounting plate off the original monitor stand and created a horizontal mounting location using a strip of plywood. I drilled a hole through the center of the plywood and countersunk the hole using a Forstner bit on the drill press. Whilst using the drill press, I followed all the relevant safety procedures. I cut a 3mm piece of MDF on the panel saw to create the basic shape of the screen cover. I tested and adjusted the fit until I was happy. I measured and marked the size of the screen into the MDF and cut it out using a jigsaw. I had to be very careful when cutting the MDF as it was small and thin and could break very easily. I cut slowly and steadily and ended up with quite a nice result. I laid out all the buttons I had in a comfortable position and tested what layouts would fit best. I then accurately replicated such layouts on Fusion 360 and created a template that could be transferred to the plywood. I then attached the template to the plywood and cut out each hole using 3 different Forstner bits on the drill press. I filled every screw hole, dent and crack with wood fill and let it dry overnight. The following day I used an orbital sander to sand every visible part of the cabinet to prepare it for painting. Once the entire cabinet had been sanded, I applied 2 coats of sanding sealer to fill the wood grain in an attempt to get the best possible finish. After 24 hours, the sanding sealer was set, so I sanded the entire cabinet by hand with a sanding block and 600 grit sandpaper. I stripped the cabinet down and applied a water-based white undercoat using a foam roller and small brush. I let this coat dry for 3 hours before applying the first coat of black. I applied 2 coats of black satin oil-based enamel paint, with the second coat being applied 18 hours after the first. I used the foam roller as it did not hold a lot of paint and did not leave large slicks that a standard roller leaves. Possibly the most satisfying and simple part of the build was adding the blue plastic edging. I used the rubber mallet to tap the edging into place and work it around the curves. This was a very simple task and did not take long. After the edging had been applied, I wired the control panel. This was a very straightforward task as there was no soldering involved and you simply plugged the wires into the appropriate positions on the board. The board itself is a zero delay USB encoder. This board simply communicates with the computer it is plugged into and automatically calibrates the control panel to work like a controller you would buy from the store. I put all the components back inside the cabinet, including a Logitech computer speaker set I found in the bin, and set them in place with some brackets I had lying around. I also tested how the controls worked in Launchbox and began configuring the control settings in each game. The games themselves were downloaded in what's called a ROM pack, and this was automatically configured through Launchbox. There are several criteria that this prototype needs to address in order for it to be successful. Firstly, the project stayed within the required budget of $350. The total cost of all materials was $339.33. This included the computer components that were either bought secondhand or found for free. The cabinet itself is an original design that takes influence from both Eastern and Western style arcade cabinets. It is innovative in shape and size, and by being smaller it takes less space and material to build. Its size also allows it to be moved very easily, and this is helped by the addition of wheels. The plastic edging and painted finish certainly make the cabinet look good, but they negatively affect the sustainability of the prototype. However, without these additions, the cabinet is designed to be as environmentally friendly as possible. The timber comes from sustainable sources, and all components except for the control kit are either secondhand or from the bin. Finally, the prototype works exactly as planned. The control panel works perfectly and the games run smoothly. The computer boots directly to the front end and everything works as it should. It is aesthetically pleasing and finished to a high standard. In closing, I can easily say that I've put more effort into this project than any other. It's been a long journey from start to finish, and I've learnt so many new skills. Overall, I'm completely satisfied with the finished outcome. It looks good and works great. Although it has been a time-intensive project, I have enjoyed it thoroughly. It has been fun turning electronics trash into treasure.